Dear students, in lecture 1, we have gone through in the discussion part of properties of concrete which are related to design of concrete structures. We have already discussed what is the compressive strength, what is characteristics compressive strength, tensile strength. Now today in lecture number 2, we will be discussing, first of all, we will be going through to understand what is the stress-strain relationship of concrete. Then next topic will be stress-strain relationship of concrete when duration of loading is greater. Then maximum compressive strength of concrete, which we have to consider for the design purposes as suggested or recommended by Indian Standard Code IS 456. So first of all, let us focus on the stress-strain relationship for concrete. You have gone through about the stress-strain relationship for steel, that is mild steel in strength of material subject. Now we have to understand effectively how the stress-strain relationship develop for concrete under different conditions. So let us try to understand the stress-strain curve for particularly for concrete. Now most of the cases we are focusing on the concrete structures as a compression member. So stress-strain curve for concrete under uniaxial compression we will be taking care of, because most of the time we will be working on the compressive strength of the concrete when load is axial compression or uniaxial compression. Now in the right side you can see a graph. That graph is a relationship between compressive strength of the concrete. Strength or stress, they are one and same thing, so it is along y-axis there is compressive stress in megapascal, and along x-axis there is the strain. So this relationship is very helpful for all of us to understand that exactly what is the meaning of relationship between the stress and strain in case of concrete. Now you can see here there are three graphs we have shown, and each graph belongs to a different grade of concrete. So different type of mix is under consideration. Now you can see this graph number 1. In this graph number 1 you can observe the behavior or the curve you see, and in this curve some part of the curve is just like a straight line, that is a linear relationship, and after that you will be observing there is a curve. That means now linear relation just has been removed, or you can say now linear relation will not follow. After that there is non-linear relation, and at a particular level of the stress or corresponding to the strain you will see there is a maximum compressive stress. Maybe in this curve you can see here is the maximum compressive stress, and that maximum compressive stress corresponds to a particular value of the strain. So here if in the first curve you can see the maximum strain where the maximum stress is in the concrete, you can observe that maximum strain value is 20 into 10 raised to power minus 3. And similarly when you see the other diagram, that means other curve, this is curve number 2. Now what we have seen here, the grade of concrete has been changed. Now and this mix has different proportions. And similarly, there is another third curve where. So what we have to understand here, that with the change of grade of concrete, you will be finding that there is some variation in the stress strain graph of the concrete, which we will discuss now. Now, as we have discussed, there is a linear curve during the initial phase. Everywhere you will find that some part of the curve is a linear curve. That means it is just like elastic curve, and you can consider that up to this limit, concrete behave just as a elastic material, and after that it is not elastic, it is an inelastic type of a material. So linear part of the curve during very initial phase of loading. So earlier phase of loading, where strain is, you can observe here strain is approximately 5 into 10 raised to power minus 3, and stress corresponding is 7 MPa. Similarly, from this graph, we can analyze that when the strength of the concrete is increasing, correspondingly, graph or you can say relationship is changing. Now, let us talk about the non-linear portion. So, what you will able to see here from this diagram, that non-linearity, when the stress level exceed between 1/3 to 1/2 of the maximum stress. Now, you see, suppose the maximum stress is suppose 35, then in between 1/3 of 35 or 1/2 of the 35, that is the maximum stress or maximum strength of that particular grade of concrete, you will find that the curve is non-linear. So that means a relationship, now it is not an elastic relationship. And another important point which we have to keep in mind, that whatever be the maximum value of stress, and each curve you will find that peak value of that curve, that stress strain graph for different type of grade of concrete, you will find the maximum value of the stress will be corresponding to a strain, that is 20 into 10 raised to power minus 3, or you can say when the maximum strain is equal to 0.002, corresponding value along the stress axis, you will find the maximum value of the stress. And for in general cases, or for usually, there is a range of concrete strength, and the strain failure you will be seeing here. If we just go through the curve number 1, after the maximum stress value, which is corresponding to strain 0.002, and you will find that strain is increasing and what stress is decreasing. So this will be the behavior of the concrete, that when you will be just seeing that strength now don't increase with the increase in the strain. So that's why we have mentioned here that strain, after that value strain, if this graph suppose it continue like this, then you will find that the failure mechanism, or you can say the concrete sample will getting failed when the strain range is beyond 0.03003, or you can say 0.003 to 0.005. In that particular range of the strain, the concrete may you observe to be getting failed. So these particular value of 0.002, which is very important for all of us to understand the complete mechanism of the concrete. Now, if we talk about the Young modulus of elasticity, which is a constant, and it is defined as the ratio of stress to strain. So that means if suppose in this particular type of concrete, you want to find out the Young modulus of elasticity, then what you have to take? You have to take the ratio within the elastic limit. So if this is the elastic range, within that elastic range, when axial stress to axial strain under uniaxial loading. So when you have to calculate Young modulus of elasticity, you can just take the tangent value of this, and accordingly you will get the Young modulus of elasticity. And corresponding, there may be a little bit change in the Young modulus of elasticity, which directly depends upon the type of loading and the duration of the loading. So in this particular type of graph, which is just uh, available when you are crushing the concrete cube in a CTM, that means compression testing machine, and you will find that the failure of the cube will take hardly 5 to 10 minutes. So that means you are applying the load on the cube of the concrete just for 5 to 10 minutes, and you will be finding the failure of the concrete, and accordingly you will be calculating the compressive strength of the concrete. But in general, when concrete is used in the construction, that means in the RCC structures, then concrete or that structure will be subjected to loading not only for 10 minutes but maybe for 1 year, 2 year, like that. So now we have to understand the stress strain relationship for concrete when duration of loading is greater. It may be 1 year, 2 year, like that. Then whether the behavior of the concrete will change or whether there is variation in the stress strain relationship for concrete, that we will be able to understand now. So stress strain curve for concrete under uh, greater duration of the loading under uniaxial compression. Now, when concrete is subjected to loading at a slower strain rate, such that the duration of the loading increased as much as 1 year or more. So that means how will be the behavior or how will be the relationship between stress and strain when the loading is for a longer period of time. So now we will be going through the details. So when you draw the stress strain curve, when the load is acting for a larger time period, you will find a slight reduction in the compressive strength, modulus of elasticity, and a significant increase in the failure strain. Stress strain curve becomes relatively flat after the maximum stress is reached. In the previous diagram or previous graph, we have gone through the stress strain curve, and you can find that the stress strain curve was a linear relation up to some uh, stress level. After that, it will be a parabola, it will be a curve type of shape. And after the maximum stress level reached, the curve is again, it is just like a curve. Now, but in this case, is this type of loading, when the loading is for a longer duration of time, the stress strain curve becomes relatively flat after the maximum stress is reached. Now, in this diagram, you will be able to understand along y-axis there is stress, along x-axis there is strain. Now, different type of curves you are able to see. Now, very first curve is when the loading is applied just for a 10 minute of a duration, which we have already discussed in the previous graph. Now, if you increase the duration of loading, it may be 1 hour, then 1 day, 1 month, 1 year, you will be finding that this curve is getting somewhat flat. That means this curve is just moving upward, and here you will be finding it just a flat curve. And let us suppose the loading is for more than 1 year, maybe for 10 years, 20 years, you may find the curve just like this for a larger duration of time. So that is the major concern here, because wherever you use the concrete in the construction, that structures will be subjected to loading throughout its life period. So how they will behave, how the stress strain relationship will develop, that we have to understand effectively before going through the design aspect. Now, what is the important observation here? Very first point is the compressive strength of concrete is an actual concrete structure, as I told, because ultimately concrete is used at a site in various type of structures. In when you are testing the concrete, you will be just casting the cubes of a standard size 150 cube, and that will be also tested under the standard conditions in the laboratory. But when you have to use that concrete in actual conditions, then you can say the size of the members of the structures or component of the structures, just like there may be a huge column or beam or slab, their size will be comparatively 1,000 times or 100 times greater than the size of a cube. So that's why this is the important point. Whatever be the compressive strength of the concrete you are getting after the testing of the cube, that may not be applicable or that may not be uh, properly usable in case of huge structures. So we can say the compressive strength of concrete in actual concrete structure cannot be granted in comparison to laboratory results, which are under standard conditions and controlled conditions. So that means we have to do some alteration in the this compressive strength which you just have collected the information in the laboratory. Now, in addition to all quality parameters, whatever you adopt, other factors such as effect of the duration of the loading, which we are in discussing just now. Similarly, size of the member, that means there will be some size effect, and the strain gradient also affect the strength properties in a real use. So in next slide we will be understanding it more effectively. So in continuation, these are the important points which we have just discussed. Now this curve we have already discussed. Now what code suggests us? How code is giving some guidelines, that mean what will be the compressive strength of concrete you got from laboratory test, how it can be utilized, or is there any modification or amendments. Now you can see there is a graph in the right side, and this graph is taken from IS 456, that is figure number 21, stress strain curve for concrete, uh, which code is recommending. Now you can see here what we have already told, that up to strain 0.002, the curve is just like a non-linear part, and at a strain level of 0.002, maximum stress is reached, and beyond that we have just considered in the earlier section that the stress strain graph will be just like a linear, or it is just like a flat curve. So you will be observing here. Now we will be focusing on first two curves. This curve we will discuss later on. Now this curve will give you the value, that is FCK, characteristic strength of the concrete. That means this is the relationship between the stress and the strain when characteristic strength is to be taken into consideration. So it is very much clear that this curve belongs to the results obtained in a laboratory testing of concrete cubes. So the value of maximum compressive stress of concrete. What will be the value of maximum compressive stress of concrete? If you are getting this value after even applying the statistical parameters, you get the value of FCK. But what will be the maximum value of the compressive strength, which you can take into calculations by keeping into consideration the above all the parameters, that mean effect of the duration of loading is taken into consideration, size effect of the actual construction you can say construction site or construction elements under consideration. And the third point is strain gradient, whatever we. So all these parameters, if we take into consideration, then what IS 456 is suggesting us, the maximum value of the compressive stress of concrete which you can take into consideration while designing and doing the analysis part. And for design purpose, you can refer clause number 38 of ISI 456, so which give us the value that compressive strength of concrete will be equal to 0.67 times FCK, where FCK is characteristic compressive strength, which we have already discussed in detail. So what you have to do, you have to multiply it with 0.67, and whatever the value you are getting, that will be the maximum value of compressive strength of concrete which you can use while designing the structures. And later on, when we will be going through the design philosophy, we will be able to understand what will be this third curve belongs to. Thank you.